Hello friends, in this video we are going to see about how to draw the Lewis dot structure of ions. I hope you enjoyed the previous video on the Lewis dot structure of molecule and remember the steps followed to draw the Lewis dot structure and classify the molecule as linear or non-linear. So let's get started with a simple ion NO3 minus. The step 1 is to calculate the total number of valence electron. So we have 1 nitrogen, so 1 into 5 plus 3 into 6. So total number of valence electron is 23 electrons. As this is an anion, we are going to add one more to the total number of valence electron. So the total is 24 now. If it is a cation, we are going to subtract based on the charges. For in this case it is anion, so we are just adding one electron to the valence electron. So the next step is to identify the least electronegative atom. In this case it is nitrogen, and we are arranging the rest of the elements around it. So now we are going to connect these atoms to the central atom by a single bond, and we know a bond is nothing but a pair of electrons, so we have made 3 bonds, so we are subtracting 6 electrons, so the remaining 18 electrons will be added to the molecule. And we know that we always start from high electronegative atom to the least electronegative atom, so we are starting from the outside, so we are start filling up the electrons as lone pairs from the outside, then we go to the inside. So in this case we have already exhausted all the 18 electrons, and now we are going to check for the octet. You could see that all the 3 oxygen has attained octet, whereas the central atom does not have an octet. So what we do is that we push a lone pair as a bond. So we are just pushing the lone pair as a bond. So now you could see that even the central atom nitrogen attained octet. So the structure drawn is stable. So we know that we can even cross verify by calculating the formal charges. I hope you remember the formula to calculate the formal charges. Anyhow, I am just giving it here for your verification. So let us first calculate the formal charges of this oxygen. The first one, this oxygen, we'll just check it out. So this should be like 6 minus 4 minus 4 by 2. So that is 0 for this oxygen. For the second one, it is 6 minus 6 minus 2 by 2. It is minus 1. So this oxygen is similar to that of this oxygen, so even this is going to have a formal charge of minus 1. And for nitrogen, it's going to be 5 minus 0 minus 8 by 2, it's going to be plus 1. So when you go for the algebraic sum of all the formal charges, we finally get it is minus 1, and it matches with the overall charge of the molecule. So now we have to identify whether the given molecule or the ion is planar or non-planar. It is simple. Again, you check for the lone pair over the central atom. In this case there is no lone pair, hence the molecule should be planar. Shall I repeat it more time? So we follow the same steps. We calculated the total number of valence electron. We added one more electron to the valence electron because of the anionic nature of the ion we have chosen. If it is cation, we are going to subtract 1. In this case it is anion, so we have added 1 electron to it. The next step is to identify the least electronegative atom and make it to the central atom. We already made it, and we just arranged the rest of the elements around it, made bonds, filled the electrons, checked for the octet. We understood that. Then we cross verified by calculating the formal charges, and we figured out the molecule is planar as there is no lone pair over nitrogen. So we'll see another example We'll see another example. So we'll start with the SO3 2 minus. So in this case, the total number of valence electron is going to be 1 into 6 for sulfur plus 3 into 6 for oxygen. That's going to be 24 electrons. So in this case, we are adding 2 electrons as the charge over the sulfate ion is -2. So totally 26 electrons. So among this, sulfur is actually least electronegative, so we make it as a central atom. We arrange the oxygen around it. So in the next step, we're going to make a bond between them connecting to the central atom. So we have made 3 bonds, so we are subtracting 6 electrons. So it's going to be 20 electrons remaining that have to be added over it. So we are going to add the electrons. So we know the procedure. We start from the most electronegative element and we move to the least electronegative element. So we already exhausted 18 and 19 and 20 electrons. Now we are going to check for the octet. All these elements has attained octet. Everything has octet structure. So the structure drawn is right. So now we'll calculate the formal charges for each of the oxygen and the sulfur. So we'll calculate for the oxygen. It's going to be 6 minus 2 by 2. It's going to be -1. So other 2 oxygens are also similar, so they're going to carry the formal charge -1. So let us calculate for the sulfur. Sulfur again, it's going to be 6 minus 2 minus 6 by 2. It's going to be +1. So the algebraic sum going to be the same as the charge over the sulfate ion. So here it is -1 into 3 plus 1. They're going to be -2. And the structure drawn is correct. Can you predict whether this molecule or ion is planar or non-planar? You could see the lone pair over the central atom. Hence, the molecule is non-planar. I hope you enjoyed watching this video. Thank you.